Other than that, I don't have a strong opinion. I have lots of opinions. You've heard them all. This is an attempt to show a lot of the ideas that we've talked about, specifically interoperability, stitched across this blossoming ecosystem of really, really cool tech. We're only going to get a couple minutes for each of the things. It's just not enough time. So if you see something you haven't seen before and you want to learn more, talk to those vendors. They can show you in much more depth than we can show in this sort of lightning round. I asked Anthony to come up first to kind of share from his lived perspective some of the challenges that we've been trying to deal with.
Thank you, Jonathan. I'm Anthony O'Freddy. I am your end customer. For 26 years, I was your end customer. I was the launch manager for Ford Motor Company for body shops, launched around the world. So I did a lot of implementations, know a lot of the data that goes along with that. And then after 12 years on the road, I went to Stellantis and ran the Jeep Wrangler body shop for another 7 years. So I am intimately familiar with this issue. And it is near and dear to my heart because I had to solve this on my own before you all, because it was just it was crazy. So what you see in front of you is why I'm here. This was my life. This is everybody's life in manufacturing, is those boards and all of those interconnections and the lack of interoperability. So when Jonathan came out to me through Steve, we met at the Pittsburgh Smart Fairs, and we just started talking, and then all of a sudden I'm here because it just fits. So just to double down on what everyone else is saying, this is the right thing to do for people like me on the floor, because there's just no way we're going to be able to survive. So just a couple things about that slide, just real quick. So cognitive overload, I haven't heard it mentioned, but there's been a lot of talking about how we're dealing with individuals and people coming into manufacturing, and how are we going to deal with this silver tsunami coming out. That cognitive overload is real. I had such a turnover running in a body shop. I had 52 engineers. I couldn't keep any of them because they were tired out. And then the new people came in, had to know 77 different systems. That's insane. We can't do that anymore. The other thing, there was a chart that was upstairs on MF, up on the, I think it was the last one that I was at. But anyway, we're talking about productivity loss. Why are we losing more productivity, human productivity, with the increase in automation? It's because 10 hours a week on average, and this is true, 10 hours a week on average of every single person in a manufacturing facility, and I'm talking about the operational people, is spent chasing data. Just think about that. If you're on a 40-hour work week, none of us here are on a 40-hour work week, we're in manufacturing. But that's a 25% productivity cut. Fix that, you get an instant bump. Okay, that's really all I want to say. Oh, so that's some of the demo that I'll be talking about, is how I solved it when I was at Stellantis, and a little bit of the software that I used, and some of the examples, and how I'm leveraging the smart manufacturing profile, which you'll see later.
So we've talked a lot this week about these three problems. Our reference architecture, if you will, that's probably too strong a term, tries to address these three problems at 3 levels. So we are going to do this demo twice, exploring how profiles are used at each of the 3 levels to provide connectivity to data, to provide context and structure for the data, and then to broker access to that structured data. We're going to do it once the way that, if you've been around CESMII for a while, you've seen us do, which is powerful and capable. And then we're going to do it a second time with some of the new members that have really dove in and committed to making this interoperability work.
So just to level set what you're going to see today with the data sources. So we went on PLC data, or sorry, CNC data sources. You've been hearing CNC a lot. The 3 that you saw down in Oak Ridge, if you were on the tour yesterday, we were standing right in front of the, actually behind was the Haas, the side was the Makino, and to the other side was the DJ Mori when you were talking to Akash and JD. So those are connected with the on-time edge profile. So we did use CNC profiles to bring the data up. And then we also have a Phoenix Contact PLC running that is running the CNC base profile. And that is what we're using as the foundation to send this data up into the SMIP. Okay? Are you going, David? At the next level. Okay. So the way this is running is we're using either the CNC base profile here, or we're running the on-time edge profile up to ThinkIQ, which is the SMIP or Smart Manufacturing Information Profile. And then the demos you're going to see today are ThinkIQ, QuickBase, SAS, and our CESMII one with our own app. Okay?
All right, so this is the demo side of things. We're going to start doing some of the demo stuff. So I'm going to share my screen here. Hopefully.
We need to go back and forth. Can you share?
I'm sharing right now, yeah. Sweet. Okay, so I am Dave Wickman. I've been with CESMII for about 4 years now. I am in charge of the Smart Manufacturing Marketplace. If you guys were in the project outcome session towards the end of the day yesterday, we kind of touched on this, and there are a couple of really good questions. So kind of go through the marketplace a little bit here fairly quickly and kind of show how some of this stuff is tied together. So if you want to think of the Smart Manufacturing Marketplace, this is like a Google Play Store or Apple App Store, but for smart manufacturing. So you'll notice in the various different areas here, we have different industry verticals. You can drill down to find different apps and profiles and hardware or processes or publishers. And then we have different featured solutions here, that are sliding back and forth. But since we've been talking a lot about CNCs, we saw a lot of CNCs on the tours yesterday. What we're going to do is we're going to pretend we're a user on this website here and search for a CNC. So if we go ahead in here and type in CNC, we go ahead and search in the marketplace. So the marketplace is going to bring back any listing that's either tagged or is associated with CNCs. So there's different apps, hardware, and profiles for these CNCs. There's been a lot of talk about profiles or these common information models. So we can drill down here and select profile. And this is going to bring up all the different profiles that we have from OPC UA, some of the stuff that we've worked on for the CNC working groups. So if we go down here and click on more info for the CNC base profile, this is the profile that we worked on with a group of other members to create a common information model for CNCs. So the really cool thing about this is there's multiple ways you can export this particular profile. So you notice here we can download this as a node set XML. We can actually view the specifications over on OPC or on just view the specifications. Then we can also view this in our profile designer. So the profile designer, I'll pull this up real quick, is a web application that we built so that way you can build out your own information profiles. And then inside of here, we can take a look at the type definitions. So this CNC base profile is made up of all these different type definitions that the working group worked on and agreed upon that these should be in a CNC profile. So with this, if you guys have a CNC or something, you can actually take this base profile and extend that profile out. So let's say there's additional attributes that you would want to have on your profile that isn't in here. That's great. That's the whole idea of extensibility and reusability of these profiles. So the next thing that we're going to take a look at, we're going to go back to the marketplace and look at CNC things again. Helps if you type it right first. And after we get those results, we're going to go over to the SM hardware. So one of the companies that we've been working with, On Time Edge, has created a really cool hardware software application called Apogee. So if we drill down into this Apogean listing out here on the marketplace, we'll be able to see all the different descriptions of this particular profile, or excuse me, of this particular different hardware, and all the different information that they have. You notice down here at the bottom, we also do have required. The required is kind of how we're tying in a lot of these different information profiles with these hardware solutions and software solutions. One of the other things that we're rolling out now, we can also start free trials. So we're working with OnTime Edge to start a 30-day free trial of not only the SMIP, but also their software solution. So it's simply filling out a form, purchasing a hardware box that can sit on that network, and then that software will be loaded on there, and then grab that information. And I believe Sue Ellen did this with a bunch of the CNCs over here in the demonstration lab. So she was able to literally just ship down these boxes, drop this software on, activate the software, and based on the machine that she was pulling that information from, she's able to take that and create instances of that machine up in the SMIP instantly. So that kind of ties those things together. But this isn't limited just to things with OnTime Edge or just with ThinkIQ, but these information models are something that everybody can take advantage of. So next up, Olivia, you're going to dive a bit more into the applications that we can build on top of these smart manufacturing profiles.
Just a quick recap. So first, Sue Ellen talked about the different machines and instances of CNCs that exist in MDF and connected to the PLC Next that are all being ingested using OnTime Edge or the Phoenix Contact PLC or Python Edge connector, using the SM profile, using that standard information model, and then sending that contextualized data to the SMIP. So we have multiple devices connected, all described in the same standardized way, and we are going to be able to connect a variety of applications using that information model. And I'm going to start with the CESMII one. So we're going to go to the marketplace with which Dave just showed, and I'm going to look for a CNC app. I find the CNC app that CESMII's developed. So this was an open source developed application that we also have a running instance of in the SMIP. And what it does is it looks for instances of an SM profile on a SMIP instance and then renders data for that CNC. So it doesn't matter what protocol the CNC is speaking, it doesn't matter how it was connected, but it does matter that it's described using that SM profile and that it's being ingested into the Smart Manufacturing interoperability platform using that profile. So when I deploy the app, I see data being rendered for my CNC instances. You'll see that there's a list of CNC instances. Each one is automatically being rendered in this application because it's been found on the SMIP. If I had one CNC on the SMIP, that's the only one that would be rendered. If I find multiple instances of that SM profile, all of those get rendered in this UI. It's looking for the particular SM profile. It's not looking for anything specific about the CNC. You can see we have a variety of CNC instances. We've got the PLC Next. We've got the DMG Mori. We've got a bunch of MDF CNCs in here. All of them are automatically ingested into the app. There wasn't a manual mapping of the tags or manual pulling of the data through the application. It's really the fact that those CNC information models exist on the SMIP that allows them to be rendered using an open API. Let me show you where that data is coming from. So in the SMIP, you'll see the same structure, the same list of CNCs, because this layer is doing the data contextualization. What you're going to see next is a variety of other applications that are also leveraging the same SM profile to do different analytics and do different things with the CNC data. I think the next one that we have is SAS. So, Paul?
Everyone hear me okay? Good. So Paul Vendetti, I'm an IoT industry consultant with SAS. And before we dive into the demo, just want to introduce who SAS is for some of you that might not know us. So we were founded in '76, so 48 years in business. And our singular focus is analytics. So we're a global leader in analytics. And that includes a lot of disciplines from statistics to AI to machine learning to deep learning to forecasting to optimization and IoT, to name a few. So we have a very big breadth of capabilities in that area. And we do this across many different industries, including manufacturing. And the kind of problems we solve in manufacturing, are things that have been discussed today. Certainly unplanned downtime, predictive maintenance, production quality, worker safety is an area we get involved with. And obviously sustainability has been a growing theme as well. And one of the things that SAS has pioneered and where a lot of our innovation goes into is what we call the analytic life cycle. The analytic life cycle is really starting from data. You got to be able to connect to data, and that's going to be a key part of the demo that kicks us off is the connection to the SM profile. More than connecting to it, you got to prepare, you got to basically govern and manage the data so you can build advanced analytics on top of that. And that's kind of the middle area of this curve where we're able to do exploration, understand the data, the relationships, build models, manage those models, and ultimately deploy them. It doesn't help if you can build models if you can't put them in operation. So the final stretch is building those models, deploying them, and in deploying them, you need to be cognizant of the fact that it might need to be run on the edge, might need to run on the cloud, might need to be both in database. So we have a wide range of options for that. And all of this in the middle is governed by the questions we ask and the insights we're trying to make or the decisions we're making. So a lot of the conversations about that, that focus of outcomes is really kind of essential to this. So with the SM profile integration, obviously they're set in this space, right? Connect, you saw Sue Ellen and Jonathan worked with us in terms of supporting us in terms of explaining and giving us access to the CNC machine in the high bay. And basically, they've created the SM profile, which for us is great because it provides that structure that is really the starting point for us. And basically, the first step for us is an integration. So with the data lifecycle that we talk about, building that integration to bring in that structure, to bring in that data is what we have achieved in working with Sue Ellen and team here. Now, once you have it into the SAS platform, what can you do? And that's what I'm about to demo. And I'm not demoing with Wi-Fi. I'm using the short little video snippets, so I'm going to be on time and not be delayed. But basically, we're going to walk through that life cycle and show you really, it's a teaser demo. I'm going to show you what's possible. It's not exhaustive by any stretch, but I'm going to show you, again, what we can do with SAS. And the first thing is now with the data in the system, we can profile that data. And profiling, so I start with the life cycle, I discover information assets. And again, we've brought in that CNC data, so I can see that data. And the first thing, we search on data, so again, you might have a lot of data in your system, so having the ability to find data is part of the feature set. But once I bring in that CMC data, there's built-in capabilities that automatically summarizes that information for you, so you know, again, what you have in the system, the format of that data. And then from there, you're able to analyze columns. And this, again, is all pre-built automatic. So you're getting some descriptive statistics on those 13 measures and also getting some data quality measures, again, all automated. So that, again, you understand at a snapshot what is the nature of the quality of data, because why go further if you don't know what the quality of the data is that you have. The next step is really being able to start to get into the next phase of it, which is kind of launching this data. And when I mean launching that data, I'm going now into ingesting that IoT data and making it analytic ready. So transforming that data into a format that's going to allow for rapid exploration. So again, picking that data set and launching it into exploration and visualization. And when I launch it, that data is now available in memory for rapid analysis. So now as a user, I can pick any aspect of this data, simply drop it into a canvas, in a smart chart generate some visualizations for you as quick as that. That's just a quick little, once the data is there, what you can do, but there's a lot more than what was shown there. So you can build reports and explore the data with a whole palette of capabilities. So out of the box, we have, again, lots of different analytics, and we pre-built 2 into this demo where you can see a correlation plot for that CNC data, time series plot for that data. And again, that shows you, again, what you can build up over time. And then in addition to that, you can, again, pick from the palette, and here we're going to show what the palette looks like, and we're going to pick one of my favorite ones. It's called Automated Explanation, and this is a really cool report. By picking Automated Explanation and dragging it in, it'll automatically set up an exploratory analysis where you can pick a target response variable like motor load rate and all the underlying variables that we have. And it'll use natural language expression to explain what the data is about, and it'll show you automatically with an algorithm that will pick the most important variable, predictive variable to that response factor and all the underlying factors. You can interact with this. So what's really cool about it is you can pick the second, third, fourth most important factor and see how each of those factors relate. You can filter the data on the fly. So again, a lot of different power that you have to understand prediction. And why is prediction important? Well, once you understand prediction, what is the predictive and that makes sense to you as a user, you can get into immediate interactive modeling. And what's interactive modeling? So right with the same drag and drop experience, I can pick out of the box features around analytics, and decision tree and regression are 2 examples. So picking a decision tree with that same response variable and underlying factors, you now can have a model built that fast. So you can, again, start to see what your predictive power is with your data, and you can copy that. This is a little bit of a hack. You can copy that decision tree and just change it to a linear regression. It remembers the previous settings of what you picked, and now you have a linear regression, so you can study the differences, and you can just keep going down the line with the different analytical methods that we have. Another feature that's really powerful is just comparing these models. Now I built them, which one's best? So we even have a capability called Model Compare. So with Model Compare, you can see all the models you built in here, select them, and it'll overlap them, so you can now see which model tends to perform best side by side with that particular exercise. So that's the power of interactive capabilities. What I'm showing you is all our low-code, no-code visual experience. We have a similar capability with programming capability. So whether you want to get into the programming or you want to do low-code visualization, we support both. And ultimately, that's interactive modeling. You want to now fine-tune your model from your exploratory. We have model pipelines. We have best practice model pipelines where we can kind of now go into fine-tuning the model. And ultimately, that's not where the story ends. That's kind of where you've built the AI ML. We got the integration of the SM profiles. We got the exploration. We got the modeling. The last part of the story that would be a follow-up for those interested is how do I deploy that? And then how do I manage it once it's deployed, which is really, really essential. Is how do I, again, make sure that I'm getting the output and results?
I just want to highlight something. So when we were working on these demos, there's a lot of people, a lot of moving parts. Sue Ellen is working with MDF to get the connectivity with the machines. Paul's team is working on this analytics, and we didn't have data connected and flowing while they were working on this, but we were able to share the information model so they could get started, and then when data flows in, it flows in and they can use it. But because we're leveraging a standard information model, that development is accelerated and it can happen in parallel. So next up, I think we have Rob from ThinkIQ. And I didn't introduce myself before. My name is Olivia Morales. I'm a solutions architect with CESMII.
All right. Thank you. I can do this. Rob Shaintaler, CRO at ThinkIQ. Going to walk you through a few examples of some SM apps that we've got available now, working with some of our partners. So, quick little mall map of where we are and what we're going to show today. So, ThinkIQ, of course, we're running the SMIP in the middle, and we're using the edge to connect to, in this case, you'll see we're using a press, not the CNC, just because it didn't have data, so we're wrestling around that. We're also going to show some of the ThinkIQ apps running on top of our own platform. We've got an example of a automated workflow. We're going to do a emergency maintenance workflow and showing how with the profiles and integrations, all this stuff can be automated and closed loop back into the platform. And then we've also got, you'll see as part of the workflow, an AI bot helping me do the repair. So I'll be wearing like 5 hats in the demo real quick to actually execute the maintenance on the motor without having to know anything about the motor, and then closing the loop out. So we'll walk through a few areas as I touch on it, okay? So let's see. First of all, I'm starting from graph model. This is stamping department that I'm looking at. How do I close this thing? Sorry. There we go. So I'm going to drill into this chassis press here over on the right. And we're going to explore that a little bit. So I'm going to jump in and look at it look at the details of it. Drops me in. I can see what it is. It shows me where it is in the hierarchical version of the graph. Should pop up for me in a second. Of course it's not. Oh, 1 sec, sorry. There we go, thank you, I can see it now. So I can see my, my chassis press, but the thing I'm interested in for this example is a motor that's having issues. And Doug, if you want to click now. So I can go in and look at the motor. It shows me some of the metrics of what's going on with the motor. One of the children objects, though, if I can drive over, is a maintenance object. And you'll see that the icon says it's a generic object. So we've got a maintenance object. I can drop on any motor that uses the profile, and this app can work with that. So it doesn't need to understand all the unique motors. It's you drop this object on. Unfortunately, OPC UA doesn't support behaviors yet. So when you think about scripts and visualizations and logic you want to attach to things, it doesn't really support it yet. So this is often how we support it. We just create a type that you can literally attach to the things you care about, and you instantly get a lot of the behavior on top of standardized objects, okay? So got another view of this real quick. So if I kind of look at the time series view, I think I got to hit last 10 minutes. If I look, so we just went red. My maintenance state now says emergency maintenance required, right? What's that? Oh, so yeah, Doug's back there helping me break it real time. So if I want to look, he injected a power spike. The motor automatically shut off, and now there it is, right? So that just happened. Behind the scenes, and I'll show after I finish it out kind of what's looking for this, but there's something monitoring, and I got in Teams a request to approve a maintenance order to go kick this off. So now I'm someone else, I'm here. I say, okay, yeah, I guess that makes sense, go do that. That goes, and then in the maintenance channel, sorry, I'm fighting with the Teams bar. And then in the maintenance alerts channel, it says a new work order has been created in service now. So I can do a couple things. I can go look back into the model to explore the details of what was going on, right, and all the context of what's happening right now in the last few minutes if I want to see what was happening. But in this case, I just need to get working on the work order. So I click over, takes me into service now, so I can actually start working on this. Unfortunately, because it's an ERP, I have to click a bunch of buttons to get through this real quick. But now in the tech, I go in, I say, great, I need to work on this. I have to go in the task, and I can kick this off. So I'm now working on this service work order. I have to repair the motor, right? It's broken. I got to see what's wrong. Give me 2 seconds to see these things because they don't default, and I have to click them, and I apologize. Get through that. Okay, so now I'm going to start work. It's a break fix, and I say it's qualified, and now I can say accept. I'm so glad to not be working in ERPs anymore. I'm going to start work. Okay, so that's awful. So now if I go back on the main motor, you'll notice that it's hard for you to see in the back. There's a second, so this is my general overview, which is kind of standard in the platform, but there's a tab called troubleshooting. So if I go here now, in the app, in the platform, I'm now presented with the AI chatbot. It's right just embedded here in the platform, kind of enabling there. This is from another company called Brick Red. And I can go in here and just start typing messages to figure out what the heck's going on. So I might want to say, well, you know, what's the serial number? I wish I could have 2 hands. And it's going to use the context of the model. So it knows where I am in the model right now. The troubleshoot. Oh, you're going to hold for me? Or can I use that? Oh, thank you. Look at this. Thank you so much. So what's my serial number? Well, in this case, the context that the bot is using is where it is in the model. So it knows that it's attached as a bot to this instance of the motor and gives me context for the motor. and it still figures it out, right? And then I might say, kind of what causes overheating, because I'm a tech that doesn't know much about this. And it's interrogating, and it tells me the source is the manual from that motor, which was loaded into the platform. So the bot's using context, the semantic model context, to give me answers, not just generic answers on what's going on. And it's right there in the platform. And then I can close it out. Now, if I go back to my service now, I think I'm here, and I close the work order. Oh, I have to give it a note, sorry. Again, I hate all this. Sorry, guys. Work notes, done, just so I can be done. Close complete. And then the integration goes back, and if I go back and look at my time series dashboard, it goes pretty fast, I think. Yeah, it started up again. So the fact that I closed the work order out, reset the maintenance object to know that it's now done with maintenance, there's another workflow, which I won't do, that's a condition-based workflow, right? But now the other thing in the platform too, it can look at the manual settings to figure out, well, how do I kind of do smarter math and just run hours, right, to kind of calculate the condition-based usage of the platform. So kind of a long workflow through to show a few integrations, and thank you for that. So how did that kick off? I'll touch on this quickly, and then I'll be done. So Techiosoft has an app that's called Smart Insights that you can attach to systems, and we attached it to the platform. And these are all built in about a week. Why? They didn't have to go understand all of the data models and stuff. They're just talking to an object that they have a known shape of, and everything else is dealt with in the platform. There's an alert that's looking, there's two alerts running, one for planned maintenance and emergency maintenance. The emergency maintenance is what just fired, because this is looking for a certain set of conditions that would say there's an emergency condition. The same tool can be used to create dashboards on top of the platform with just exposed objects, and it gives you simple visualizations, nothing like what our friends at SAS can do, right? This is just nice visualizations on top. But all just kind of snapped onto the top of the platform, and all these are from different vendors. We've got workflow, et cetera, all integrating, but it was all done very quickly because no one of these partners had to go figure out the database model and all those things to get this done. They're working off of types. And any instance of a motor, I drop that maintenance object, will work the exact same way. Helpful? Quick flyover? All right, good. Thanks, everybody. Stop sharing. Sorry, guys. There it is. All right, who's up next? I don't know if he needs a holder or not. Thank you.
Okay. Whoops. Somehow I went to the beginning. I don't want to be at the beginning. Here we go. Okay. Just to pick up where we started from, fully plug-in manufacturing applications. The problem, from my standpoint, being the end user of all the data, and let's talk about QuickBase. So the QuickBase is a no-code relational database. It sits on the AWS platform. We're hosted by AWS. We've been around for 20 years, just to give you a little bit of introduction. You probably never heard of us, but we are in the background of so many different companies, but just entering into the manufacturing space because of the need for it, really. I utilized QuickBase. I brought it into Stellantis in 2018, and I needed to fix the problem that you saw before. What it does is it leverages the smart manufacturing profile. And I'm going to demonstrate that here in a quick second. If the platform is fully mobile, it brings in all that new technology that the new workforce wants and is dying for. So getting into what I would consider where QuickBase fits in with all of you. We fit at number 5, we're the application layer. We're on the top. So we can communicate with the edge. We have APIs. We're open. We can talk with anybody. We can build APIs, Lambda functions, whatever you need to communicate. We can communicate with all those other systems. What QuickBase does is it provides the asset shell integration, because not only can I bring in all of the manufacturing data from the floor, but I needed to marry it to all of the other enterprise data. That's the key for making my life easier on the shop floor, because my LMS system, my ERP system, my MRP system all needs to be connected to my machine manufacturing data. So that's in essence on how it works. The beauty of the platform is that anybody can program in it because it's no code. So talking about the smart machine profile, smart manufacturing profile. So I took the profile that was provided from CESMII, and Sarah in the back sat down with me, and we actually built out this this application. So each application in QuickBase is a series of fields and tables, and those is what we combine together to create this smart manufacturing profile. This connects through APIs to your operational layers that you provide. We don't do this, we take summary data, we don't do any analytics with that, we don't do any AI with that. We can do it with the summary data, but not to the detailed level that you all do. Getting into, it also can provide insights because we are a platform that can provide insights, absolutely. But what it does is it starts connecting, and you can start building upon the single source of truth. If there is one big problem on the manufacturing floor, it's figuring out what your source of truth is and whether or not it's valid. Now we can do that. This is connecting to the CMMS application, which is built in QuickBase 2. So I'm going to flip over to that live. So switch out here. What you see in front of you is a dashboard of the applications that are built upon the smart manufacturing profile and the enterprise data. As you can see, they're broken out by role and workflow. Now, those roles and workflow, like maintenance, need that manufacturing data that we've been talking all day about. So how does that work in the background? Well, each of these apps are interchangeable and interoperable with each other because we have in the background what we call parent data or central data management strategy. Inside of that central data management strategy is what all of the applications are built on. This is what connects to the operational layer. So now that you have the source of truth, you validated the source of truth, no one touches the data layer inside of QuickBase except for the realm administrators. Everybody else builds the apps using that source of truth. No more Excel sheets floating around. No more trying to figure out if my data is real or not. It's all built in the background. And you can see I just have a few of the tables that are built in there into the parent tables, but it's all built across the back end. So now that you know how the data is governed, how do the apps get built? Well, they're built by yourself. You can probably build them in a couple days using the data, or you can download pre-built applications that we have. And this is always in the way every time I present. Okay. Let's go back here. Okay. And let's go to the CMMS profile, Pro app. So what we call them Pro apps. But these are all available in our exchange, and then after talking with CESMII, we'll try to work out so that it can be available in the exchange here as well. They're free with the platform. All of this data is what is interchanging with that smart manufacturing profile. And if I were to click on the smart manufacturing profile, you can see that it's bringing in some of the data already over from the CMMS platform. And this can do it with shop floor management. You can bring in all sorts of kind of data with that machine or that asset. And if I click on the individual events, I can actually start looking at different mills. I can look at different assets. I can filter them. But in general, what I'm going to do is just look at one. So let's just look at this first one. It's going to pull up. Where's the, whoops, wrong one. It's going to pull up a CNC mill, tells me that it's running, tells me what my minutes per day are. But that same asset tag is the same asset tag that is used in all that is used across the entire platform. All right, now going back, the other piece of this is that knowing where the right person is at the right time at the right job. Scheduling, this provides that availability because now you're tying your machines to your manufacturing data and able to track your LMS systems to making sure that you have the right skills at the right job. And that's what QuickBase does. So if you have any other questions about it, be more than happy to demonstrate, be more than happy to tell you about my journey with what we're doing here at Stellantis over the last couple of years, and we'll be in the back. Thank you very much.
what you just saw was kind of our traditional approach. ThinkIQ provided the spine. They have been our faithful SMIP for the past 5+ years. And we've connected data from a variety of data sources, OPC UA, MT Connect, and OnTime Edge provided an adapter that actually used their API to pump data in. Their platform provided the organization layer, instantiated the objects for each of those CNCs, and then the API that these applications connected to. So they were all using that API and that profile. The brave new world that we're launching on right now is the fact that other platforms need to be SMIPs. And that's what we're going to try to show in the second half here. So John, do you want to come up and give us just a quick overview on HiBite?
Yeah, thanks, Jonathan. So actually, Jonathan is going to show the demo. So I'm going to walk through a couple of quick slides just to introduce you to what we're doing, and then Jonathan will do a quick demo. So HiBite, that's not my slide.
Oh, those are your slides. I'm really sorry.
That's okay. Sure. So okay. So HiBite is a data ops platform. Data ops, for those of you who are not familiar with it, is really this discipline around integrating systems. So we talk about how integration is what's killing a lot of these projects. Integration is so hard, it's consuming a lot of time. The IT industry started using the term data ops as the description for the practices that we put around data ops, or around that integration. So think of it as an integration platform. I got no slides, I'm not doing a demo, and the mic is dead. Anyway, just tell me when I got to get off, Jonathan. So HiBite is an interoperability platform. Okay, we looked at the market back when we founded the business. I'm the chief product officer. I'm all messed up here. He screwed me up. I'm the chief product officer and one of the co-founders. We founded the business in 2018 and looked at the market and saw the exact same thing that CESMII did in 2016 when they looked at the market, that data is broken and we need to make it more interoperable. We took a very horizontal approach and said, look, there's lots of data sources in a factory. There's the telemetry data in OPC, there's MQTT, there's systems that write reports and CSV files, there's SQL databases, REST APIs, and we need to consolidate this data, transform it, standardize it on models, and then land it where people want it to go. We didn't know about ThinkIQ at the time, so we're landing it in the cloud. We're landing it in Snowflake and Amazon and Azure and Google. We're landing it in influx databases and MQTT brokers. And the key was, how do we standardize that data so that people could easily consume it? You good? You got your demo?
Yeah.
All right, get the demo set up. I'll keep talking. So that's what we have. We have an application that Jonathan's going to show off, and it runs generally on-premise. It's a standalone application for moving this data, and then you can link it up with others. You can federate it and move data wherever you need it to go. With that, I'll turn it over to Jonathan. You can show the demo. Thanks, man.
Can we give him a round of applause for being a good sport? I was trying to get this up while you were talking. This is one of the things I'm super excited about. Look at all of these connections, like all of the places I can connect to, both to get data in and to get data out. That's friggin' awesome. But what's really cool is what I can do with that data as it passes through HiBite. So really briefly, this is the test app that we quickly whipped together to show CNC data visualized, and this is running against the ThinkIQ version of the SMIP. This is the profile that we used to do it. There was a good question I got over email on the profile. Why should I use this one? Probably shouldn't. This was the one that CESMII members collaborated on to kind of unblock some project work. And so we used it here as a useful pivot point for these demos. So that profile defines some types. I've implemented those exact same types inside of HiBite using what they call modeling. I've also been playing with my solar charger, so I'm going to filter on the CNC base profile. So these are the exact same types that are in the marketplace, in the profile designer, but implemented as models in HiByte. CNCs have an axes. The axes belong to the base type. I can then instantiate them into objects. And the way that I'm going to get this instance is via another new CESMII member, HiveMQ. So I have a CNC simulator. We recorded the data from one of the CNCs that didn't speak MQTT. I wanted it to, so we play that data back over MQTT to a HiveMQ broker living in the cloud. And this is what it looks like in its raw, unmodeled form as it's coming out of the CNC. That raw, unmodeled form can come into HiByte as an instance object. So here's my MQTT CNC sim. And if I test the instance, I'll see the data. But that data has already been squeezed into the model by HiveMQ. This instance is of a type, in our language, of a model in theirs that defines the structure that the data needs to fit into. What's really cool then is that I can take a pipeline in HiByte. So here's my CNC pipeline, and I can do whatever I want with this data. So I'm reading the payload over MQTT. I'm applying the model. I'm squeezing it into that modeled form. And then I am writing it via a tag provider directly into Ignition as a structured object. At the same time, I'm restructuring that data and republishing it to my quote-unquote unified namespace back up in HiveMQ. So here is that same machine, but now structured according to the profile that CESMII members have decided on, forcing this unstructured data over MQTT to meet the structure that all of these applications are working against. If I switch over to Ignition here and delete this tag, wait for the next MQTT publish, the tag reappears, and there is the structured object now as a tag in Ignition. And along the way, it also created the UDTs for me that are compliant with the type definition. Travis helped me, and we were able to very quickly bind that structured object to a dashboard in Ignition. So end to end from a raw data source into a model via HiByte, and then out to my MQTT broker or into Ignition, in both cases as a properly structured object. That's version 1 of this. We're using HiByte to clean up things that weren't clean to begin with. There's so much more that I could do in HiByte that I've started playing with my own IoT data. But there's another path to accomplish this, to get structured data into an HMI SCADA, and I want to invite Travis up to show us how that works. Maybe an hour to a day for 2 weeks. Yeah. And I saw only your marketing material before. So when 4.0 hit, I picked up the Docker container. It's running on this machine, and mostly figured it all out on my own. I want to show just one more thing. Sorry. You can have screen sharing back in a second. We talked earlier about APIs. I want to show you really quick that because this object that is flowing through HiByte meets the model, I was able to adapt our little test app to the HiByte API. This is 100% the same app, slightly different API calls because we haven't harmonized an API yet, working against that same instance object as if HiByte were a new SMIP. All right, now it's all you.
That one. All right, so what I'm going to show is here with Ignition is right now we have this as an Exchange resource that you could bring into an existing Ignition 8.1 installation and to be able to bring in those SM profiles and basically create UDTs within Ignition. In the next release, 8.3, it's going to be baked into the designer, to the experience, so it'd be really, really simple. Along with if any OPC server device that supports those profiles directly, we won't have to do any conversion whatsoever, because through the OPC channel, it'll automatically be UDTs in Ignition. So these are this is going to be more of an example of how do we get legacy brownfield type devices mapped into a UDT so I can use it. And then I'm going to show one level further, which is then to bring it into MQTT, as controversial as it is, to show how we can go a little bit further. So what I'm going to first do, like what we have in there is browsing. So basically connecting to CESMII's profile library or cloud library, or of course going to OPC UA or any, boy, this is nice and slow, any custom one that you may define. So here's that same CNC-based profile. So sorry, we're going to use the same one over and over again. And the idea, of course, is to then import that. And right now, I don't have anything in Ignition, the designer. So there's no UDT definitions. We don't have any tags in here yet. I want to bring that in from by importing it. So we've imported it. The one thing for our tag structure, our UDTs, is that we don't right now currently support arrays of objects. That's something we'll be doing as we go forward. So what we're basically having it do is just letting the user define how many instances of these things are going to be in each of these objects. So if it was 1 or 2 or however many, that is. So let me just do this real quick. Sorry, one hand would have been faster. But in particular, when I get down to, so you can see all of the actual types that Jonathan showed earlier. These are all the same ones that are here. I'm going to do those actually add 3 axes. And we're going to do X, Y, and Z. So I'm going to copy. And there we go. Save, and I just have, sorry, a couple more. So it's okay. There's a lot of the arrays of objects. Again, we'll have that direct support within Ignition. So I'm going to bring that into my test provider, import those UDTs, and that part is now done. So in here, I'm going to see the profiles. There's all of the CNC types. Of course, there is that base type that we're talking about. And what I would do now, of course, is instantiate that. So we're going to create a new data type instance of that CNC base type so that it follows that structure. Again, that makes things a lot simpler when we use these. I'm going to go CNC1, and we parameterize these. So I have a CNC simulator behind the scenes that's exposing data through OPC. And but it could be like a Modbus device, could be Allen Bradley, it doesn't matter, right? Any kind of device. You want to hold for me a second for a second? Yeah, it'd be a lot easier if I can just do this. Oops. CNC. Why is it doing that? There we go. And then Ignition. Okay. So I will then create that, and there's my instance that is of that type. And if I expand all this, you can see, of course, that the data is all coming through the way that we expect it to come through. Now, of course, what's cool about definitions in the world of Ignition is that I can go in and for any of these, I'm going to go to the axis objects here. For the axis, let's say that this offset, I wanted to historize it or alarm it or any of that kind of thing. Let me do history down here, turn this to true. Once I set that up the first time, every instance that would come in later subsequently would have the history and configuration already set up. That's the beauty of it. Plus, then I would build templates for visualization, or I'd build applications off of that type. So then I can do something like this, which I think is the coolest thing. Take CNC, and he showed that visualization template. I'm going to drag it on the screen and create the same visualization template off of that type. So when you do this, it makes things so much simpler to be able to develop on as you're going forward. Now, we could take that one step further. This is in Ignition. We have leveraged getting the data from OPC from different devices into this. In the next release, we'll expose that through OPC UA as data models. But right now, I can show getting that to MQTT through Sparkplug, which defines UDT templates as well. So what I'm going to shift over to is this MQTT engine. I don't have anything subscribing yet to the broker, so nothing's coming in. What I'm going to go here do is I have MQTT transmission in Ignition, which will publish tags just so you can see what this would look like. It's going to go to a server I have locally, and the transmitter is to take the tags in that test provider. So that's this test right here that has just the CNC right now and all the definitions. So sorry, let me go back to engine. Again, there's nothing in here yet, right? Oops. Sorry. There we go. So nothing in here yet, no definitions, right, on the engine side. So okay, here we go. So we're going to go to the transmitter and we're going to turn it on. I'm going to basically set it to publish that data to the broker. So now I've got 1 and 1, meaning I'm connected. I'm publishing that object. On the birth for MQTT with Sparkplug, that whole definition, the whole model SM profile was delivered, and any subscribing node would be able to see that. So I'm going to show Ignition, but imagine it was some other product. So if I go to engine, I see there's the same profiles that were automatically discovered through Sparkplug. There it is. And there is, if I go down to RI Edge, this device, there is that CNC1 that has everything inside of it and the data coming through same way. So taking that and being able to have that single source of truth defined at the edge brought through the entire organization. Now, if that's Kafka, if that's MQTT, if that's a REST API, and in fact, when the API gets, I looked at it today, super easy to implement when it comes out, then you can connect to Ignition through an API and get the same model information. But I think what we're all sharing here is really important. It's once we have that definition created and we're all following the same model, it's incredibly simple for all these products to just bring it into their ecosystem. It's not a difficult task. I can integrate with every one of these products now that we have it. So that's my demo.
So I kind of have chills. One, because I didn't know if we would get all of it working. I'm really sorry about your slides, John. But I think real software is better. Far from perfect at this point, but we had Phoenix Contact, we had On-Time Edge, we have ThinkIQ, we have Brick Red, we have QuickBase, we have HighByte, we have inductive automation. I'm sure I missed some, all kind of interacting with this concept of a common information model enables interoperability, and a variety of choice enables manufacturers to start their journey where they have a felt need, but do so in a way that enables them to continue to grow and choose different software packages for their needs so that they can continue to build on these standards and build towards a knowledge graph that helps them make better decisions. So huge thank you to everyone who helped with this demo. I'm pretty pleased that most of it worked really well. I think we have a minute for questions if there are any. I feel pretty good. Yeah. All right. Well, if you have questions for the vendors, I don't pretend to be an expert on much of this software, but we're all happy to share how we started to explore getting it working together. Next year when you come back, there's going to be even more software and even cooler demos. So thank you for being in this ecosystem with us, for pushing this forward with us, for demanding this interoperability. I think there will be a closing session next door shortly. So thank you very much.